So I'll try to cover briefly within 15 minutes. So what nebulizer to use for which application, right? Which is always a struggle for ICP users. So there is a outwhelming source or choice of the nebulizers on the market, right? Each manufacturer offers it, so there's pages and pages of it, and which one to use is the question. When we ask, or when we work with you, it's asked, what type of nebulizer do you have? And most often we get, this is just what came with the instrument, right? Which, if you're lucky, it could be the one, or it could be what's called the default one that your ICP or ICP manufacturer is supplying it with. So it may work, it may not. So ICP manufacturers, and this is the table from Agilent, so they try to come up with the overview and give you an idea what nebulizer to use and put multiple columns like you see here. And then you have to go through, and I'm not criticizing that, that's a good starting point, but it's actually hard to see, which nebulizer to pick and kind of make a choice based on, on red or green, whether the RSD is good, with the sensitivity. So about a year ago, when I was preparing for our presentation, I came up with this fantasy, right? What ideal nebulizer would be. And that's, I don't know if you all saw this old commercial, set it and forget it. So this is the ideal thing, right? So when running your ICP or ICP-MS, you have enough things to worry about the nebulizer. You have the exhaust, you have your sophisticated system, you have your optic, or you have your ICP-MS interface, quadrupole, collision cell, you name it. So the nebulizer should be the last thing that you should worry about, right? In ideal world. And for that, it has to be robust and reliable, it has to give you consistent performance, and ideally, you don't need to maintain it or maintain it at a minimum. Is anyone who wants to clean your nebulizer every day? Anyone? Raise your hands. No? Weekly? No? Okay. That's what I thought. So the most common nebulizer that probably comes with the instrument, unless you have a special application, is the concentric type. And that was developed in the last century by Dr. Meinhardt, that some of them call it Meinhardt type. So it's a basic concentric nebulizer. It works well because people like it for its high efficiency and a good precision. But as you heard today, it struggles with two things, particulate content and certain types with salt content as well. And I'm not going to go in the details of the geometry, but yeah, you get this deposition that could help on that could happen everywhere in the nebulizer, inside, between the outer tube, inner tube, on the output of the orifice. And the reason it does that is because in the concentric nebulizer geometry, because of its efficiency, everything going from wide to narrow, sort of like a traffic jam that you see here, right? So that's what's happening here. So when you run clean samples, there is nothing wrong with concentric nebulizer. And my suggestion is, if you don't have to clean it every day, then it's fine. There is nothing wrong with it. So clean samples, also self-aspiration. Concentric nebulizers self-aspirate. And we offer it as well. We don't build concentric nebulizers, but we offer it through our partner, Precision Glass Blowing. So Erica is here. So they make excellent nebulizers, and we have no problem to offer it to you as well. So, but when it comes to something like that Melissa showed in her presentation, so it's probably a better choice to look for what's called high solids capable nebulizer. Or the other thing, if you run any petrochemical samples. Anyone from petrochem industry here? No? So that's how these samples look like. And in this, even ASTM method calls for so-called Babington type nebulizer, which is the robust, non-pluggable nebulizer. So the other, and I would put this as, this is more extreme application, a more demanding application than even the oil-filled brines that Melissa was talking about. That's called DEF, or diesel exhaust fluid. You see here on the reason I put these pictures is, this is the bottle with this DEF, and you see here it's crystallized outside, right? It's versus 30% urea. It's instantly a crystal. So here is the picture of just in the vicinity of the rinse station of the water sample. So it's just probe moves, drop, and this is what you got. Imagine what it's going to do with your nebulizer. So for this type of thing, we suggest to operate with so-called non-concentric nebulizers, or we call the improved dual channel. Sometimes it needs to go to parallel path or whatever. So where sample and gas are separated, and that allows a pretty large opening for the sample. And that, as Thomas mentioned, is 1 millimeter on our nebulizer. This is the last version, we call Optimist XL. And the reason it doesn't plug is very simple. So remember I showed you in the concentric, it goes from wide to narrow. Here is the other way around. It starts with a probe, which, 0.5, 0.75, sometimes now probes are going to 1 millimeter opening. And then the sample capillary that connects is half to 0.75. Some manufacturers using 0.25, but that's too small for heavy particles. So you get from 0.5, 0.75 to 1, so guess what's going to happen with particle, right? It's going to go through and get spit out. That's why these type of nebulizers do not clog from particles on your sample. They still can get blocked on the gas if the high salt present, and that is handled with argon humidification. So when we introduced Optimist XL back, I think in 2018, I made a presentation at this conference. So then we get a question, well, do you have HF-resistant version of this? And we didn't. So we developed HF-resistant version. That was the driving force for that. And we came up with making it from two materials. One is Altem, or polyethyramide. The other one is PEEK. So the reason I picked up Altem is because I've noticed that there are autosample probes made from Altem. So if it's good for the autosample probe, it should be resistant, it should be pure enough, right? That's what we care about. We still keep it in two materials. Some people used to see the PEEK nebulizer, so we keep it in PEEK and the Altem as well. Performance-wise, they're pretty similar. I mean, there is no any actual difference between them in performance. It's more question of the choice, of your preference. I'm sorry. So the nebulizer is made from. So let me go back for a second to this slide. So they're single machined nebulizer. It's a single piece. So draw. Step with my 250 pounds. Nothing, right? So I cannot break it. So that gives robustness. Of course, you don't treat your nebulizer like that, but just to kind of show you, so that's what it's a single piece. There is no other parts. You just connect your gas and connect your sample. So which gives your people who operate the ICP this forgiveness, right? So you don't have to, like remember I said it, set it and forget it. If you drop it, don't worry about it, right? Okay, so the now I mentioned how to run, what to do it with when you really need to run high salts or DEF or anything like that. So that, in addition to a high solids capable nebulizer, so you benefit from getting what we call additional or makeup gas. And this is a few examples of it. This is on Spectra ICP. These ports available on other instruments. I believe this is Agilent, this is Thermo. I don't think it's available on PerkinElmer, but it can be held through the external loss flow control. So if you really need to get the better reliability of rank high source, this makeup, additional gas, helps a lot, and you bring it right through this adapter. Yeah, that's the port for the additional gas. So, briefly, performance. So when you, in some application, where you don't need just to worry about clogging your nebulizer or salting it up, but in addition to it, you need to hit your detection limit. So this is where you need not just the robust nebulizer, but it gives you good sensitivity. And that's a real challenge for all high TDS capable nebulizers. Here is the example that from one of our customers done in urea, and you see 50 ppb potassium, so you get 0, 10, and it's kind of in the same level, but this is 50 ppb spike of potassium, and potassium is one of the most difficult elements to handle here because of the carbon-related bands. So also people can introduce oxygen to burn it, to make it better. But here is what can be done with all this setup and this nebulizer. So here is the 50 ppb point on the curve. So we did it with PerkinElmer as well, without additional gas. And here you can see on the picture the Optimist Extreme nebulizer, well, that's made from peat. When we got contacted, so this customer would not run a single sample of DEF per day. And not just because, I think they have a right nebulizer from PerkinElmer, highly soluble, but there was no argon humidifier there. When I first saw it, I said, no, you have to put a humidifier there. So we got him. So they also put our nebulizer there. They get a kick in sensitivity by factor of 2, going from the current one, and then they're running flawlessly, and they're extremely heavy. So then, when you need to go very low on your detection limit, this is where sensitivity is an issue. What to do in this case? Back a couple of years ago, we collaborated with our friends in Organic Ventures, and so I saw they did a presentation on running Big 4, which is arsenic, cadmium, lead, and mercury in cannabis, and that's industry doing it by ICP-MS. And I said, wait a minute, what if we try to do it by emission and just get them the efficient system? So anyway, long story short, we've done it, and it was published in Spectroscopy of October 2023, and that was done with this nebulizer that's called Optimist Vortex. You can see here, it is very interesting geometry. So it is also the dual channel. It's separated, but it has an impact plate. So when the mist, sample goes in, it creates the mist initially, like in our Optimist Excel or Optimist Ultimate nebulizer, exactly the same way. And then it meets this impact plate, so it hits it. And then the mist is getting dispersed to finer particles, and this is how you get the efficiency. On some of my other slides, I show like a waterfall. So you get this like a mist nature happening in the waterfall. So this is the same effect there. But the benefit of it, you not just get the kick and sensitivity, you still keeping the robustness of dual channel design where you're not going to struggle with particles or clogging from particles. So here how it is set up on the instrument. So the nebulizer you have to just kind of twist it, right? So it has to have certain orientation, and so that the impact plate is positioned this way, so the mist is shooting up here between the baffle and the wall of the nebulizer. So this is how it is set up on Agilent. And here is the example. So Precision Planting is a company who reached out to us and they want to get a boost in the detection of certain elements that are they're doing very innovative work. So they get this system from radar, so Mike is right there, and then we said, well, that's probably what you need. Yeah, for robustness, you would need something like Ultimate, but if you really need the kick in detection limit, you need the vortex. So they set it up, it's running. If you want to have ask how Rachel like it, she can tell you all about it. And this is how it is set up on Perkinoma. So this is, so you see this picture right there, so you see this orientation. So kind of horizontal gas channel should be here to get the mist right where it needs to be. Now, going to ICP-MS, right, as Tom mentioned, the modern ICP-MSs are designed for smaller sample uptake rate, 0.4 mils per minute typically, right? And we offer, again, through our partners, there is a basic concentric nebulizer, I call them micro nebulizers, so for the microflow, glass of quartz, and then we also the PFA one through our partners as well. So that's all the choices you can get from us and you can get it from your old supply. So that would be again, something that you run on a spec, it doesn't clog, it's not very challenging sample. So that's what we would recommend. But if you have something like that, right, which is the whole blood, dilute and shoot, so you have this protein coagulation. If you run it through concentric nebulizer, it's going to have the same story. You have to stop, clean it, unblock it, and all of that. So there is a paper that we just published in spectroscopy of September of last year, and that's this issue called Advancing ICP-MS and Best Practices. So enhancing ICP-MS efficiency with innovative low-maintenance nebulizer. And here it is. Yeah, you can look at this publication, but this is the snapshot of it. So if you look at this nebulizer, which we call Optimist Ion, you see something similarity with Optimist Vortex. It is the same idea where a mist goes and hits the impact plane. But the key here was to make it work for the smaller sample uptake rate. Vortex is not going to work. It will work at 0.4, but it will struggle with precision. Here, we designed, the reason it was patented, it handles smaller sample uptake rate and provides this robustness and unpluggability as well. So just to take a quick peek at it, so that's what the work was done by Mary Kay at the University of Arizona. So she ran blood samples back a few years ago. We presented the poster 2 years ago, and that's also part of the application. So there is you can see how the glassware looks like after this run, but the nebulizer itself, it's like nothing touched it. So in 2024, yeah, so she made a poster on increasing efficiency with challenging matrices by innovative nebulizer. So at this poster, she presented, it was data presented of running 17,000 samples from period of September 22nd to June of 2023. No blockages, but what most amazing, no maintenance. So she didn't touch the needle. If you don't believe me, here she is, Mary Kay. All right. So then we tried to look further in Nebulization. So what was done? So then she calls me around June of 2025 and said, oh, Sergei, I think something is, back pressure is high on my nebulizer. And I said, okay, yeah. So then we just get to the procedure to clean it, just put it in the torsion socket and back in operation. So by that time, she figured it was 31,000 samples were run without touching anything. So here she is. So she's gonna do a poster tomorrow, TP41, and I'll give you a bit of a teaser. So what we noticed is mercury actually got a kick in sensitivity with Optimist I and Nebulizer. And I have thought about it. So when the flow hits the impact plane, it slows down the velocity naturally, right? You can have a barrier, right? And with a slow velocity, if that's true, it goes and increases residence time in the plasma. And mercury has the high ionization potential. When I look at the table, I couldn't believe my eyes. It was higher than phosphor and sulfur. So it's known effect with a longer residence time, you get a better performance on the high elements of high ionization potential. That's probably what's happening. But you can see here, she managed to put 1 ppt of mercury on the curve. So you can take a look tomorrow. All right, and to conclude, so we put this a bit of a ambitious, I would say ambitious term in next generation nebulization, which actually comes from marketing of our partners. So, but what it is, why? So the dream nebulizer I was talking about, right? If you kind of summarize, it should be high solids capable, handles particulates, HF resistant, but also the key thing there, because there are nebulizers on the market that do all of that, but at the same time, to do get the sensitivity that's been shown by Thomas and Melissa with her 4 ppb detection limit of force, and the precision, because how I was taught, and how probably some of you were taught, if you want to get high solids capable nebulizer, you have to give up precision and sensitivity, right? I think what we see here and what our customers, you guys see here, that's not the case with nebulizers we're talking about. And to conclude, so here is the story. So again, this customer was brought by our partner, Alisa is here, and I contacted to him, and then I invited him to be a presenter today, but he couldn't make it. And I said, okay, Don, please, could we just write it down? What is your experience with our Nebula? And I can just read it to you. So they have all Agilent system. They put successfully installed on 3 Agilent OES, had 0 clogging or sensitivity issues. And we send them Optimist Vortex nebulizer. So this is the environmental layer without geochemistry. So there are some particulates in their samples. Not bad, but with the nebulizer they've got, they get actually PFA nebulizer, the design for ICP-MS. How it get pushed to ICP emission, I don't know, but that's what's happening. So then they're gonna buy a 4th 5800 soon. So they will have a bank of 4 identical systems, Agilent, all with switching wells and all with your nebulizers. In mind, your nebulizers. So then, from a cost standpoint, just if some of your lab managers are here, we were still doing things old way if that would have costing us $50,000 per year on the nebulizers only. They were going through 1 nebulizer replacement per instrument per month, because after it clogged, they try to clean it, and then it quits on them. And then they go and buy a new one. This is what was happening. And it's happening not just with that, we see it all the time. So then, this is not inclusive of the cost of downtime, lost efficiency, rework, and labor. Reanalysis is expensive, time-consuming, and a real threat to the efficacy of the lab operation. Your NABs put a huge dent in the amount of rework needed as a result of failed analysis due to clogs and failed sequences. I cannot say anymore. Thank you. Questions, please. All right, so we have to, my partner told me that we have to rush it out.